global average temperature, warming asymmetry has increased at a rate of 0.18 to 0.29 degrees Celsius cubed per decade since 1900, a measurement that suggests our traditional focus on global average temperature is fundamentally masking the true nature of climate change. We've long relied on the global mean surface temperature change as our primary health check for the planet, but it turns out that single number is increasingly hiding a massive regional divergence. When we look at the data through the lens of 58 IPCC reference regions, the picture shifts from a balanced global warming to a system where a few specific areas are pulling the average away from the reality experienced by most of the world.
It's a critical shift in perspective because that global average assumes a sort of symmetry that simply doesn't exist anymore. Historically, we could look at temperature changes and see something resembling a Gaussian distribution, that classic bell curve where most regions clustered around the mean. But this research shows that we're moving toward a highly skewed bimodal distribution. Essentially, the climate system is splitting into two different states. You have the outliers like the Arctic Ocean, Northwest North America, and the Russian regions, which alone account for 48% of this increasing asymmetry. Then you have other Northern Hemisphere mid to high latitudes adding another 35%. This means over 80% of the divergence is concentrated in these specific northern zones.
That concentration is staggering. If 83% of the asymmetry is coming from just a fraction of the globe, it implies the global mean isn't just an average, it's a value skewed by extremes. If I'm living in a region that isn't the Arctic or Siberia, the global average I hear about in the news might not match what I'm seeing out my window at all. Does this gap between the official global number and local experience actually change how people perceive the risk?
That's exactly the concern regarding cognitive bias. The study highlights that as this gap widens, it can foster a serious disconnect in public awareness. If the global mean temperature is rising faster than what people in the majority of regions are experiencing locally, they might conclude that the threat is being exaggerated. It's a psychological barrier where personal experience trumps statistical data. This isn't just a minor misunderstanding. It could actively undermine public acceptance of the very mitigation policies we need to implement. When people don't feel the warming at the rate the headlines suggest, their sense of urgency drops.
It creates a dangerous illusion of safety for the average person. And the research suggests this isn't a linear problem either. Looking at the different emission scenarios, the shared socioeconomic pathways, or SSPs, the acceleration of this asymmetry is highly dependent on how much we emit. Under a high emission scenario like SSP5 to 8.5, the trend in asymmetry is projected to be 3 to 8 times greater than under the more moderate or sustainable paths like SSP2-4.5 or SSP1-2.6. We're essentially choosing how much we want to break the internal coherence of our climate's temperature distribution.
The nonlinearity is the most alarming part. If we stay on a high emissions path, the divergence within the climate system doesn't just grow, it explodes. The bimodal distribution means that instead of one global climate story, we end up with two vastly different ones. One story for the rapidly heating northern extremes and another for the rest of the world. But because those northern extremes are so intense, they pull the global average up, making that average look less and less like the reality for most of the human population. This widening gap between the global mean and regional observations is a systemic breakdown of how we measure and communicate climate change.
So the metric we've spent decades training the public to watch might actually be the thing that ends up confusing them the most. If the Arctic is warming 4 times faster than the rest of the planet, that extreme pull creates a global mean that is statistically accurate but practically misleading for a farmer in the mid-latitudes. Does the study offer a way out of this measurement trap? Should we be moving away from the global mean entirely as a policy target?
It's not that we should abandon the global mean, but rather that we need to supplement it with these measures of asymmetry. We have to recognize that warming isn't a rising tide that lifts all boats equally. It's more like a seesaw that's being weighed down heavily on one side. By quantifying this asymmetry, we can better predict where these cognitive biases are likely to take root. Rigorous emission reductions are presented as the only way to prevent this distribution from becoming permanently bimodal. Without those reductions, we aren't just facing physical climate risks, we're facing a total collapse of the public consensus needed to fight the problem.
It's a dual threat scenario, the physical acceleration of heat and the psychological deceleration of the will to act. The fact that the Russian regions and the Arctic contribute nearly half of the trend is a reminder of how sensitive the high latitudes are, but it's also a warning that the average experience is becoming a myth. If we can't align the data with people's lived reality, we lose the argument for mitigation before it even starts. The divergence isn't just in the atmosphere, it's in our collective understanding of the crisis.
Exactly. The bimodal shift is a signal that the climate system is losing its stability in a very specific way. When the distribution of temperature change stops being a simple curve and starts having these distinct peaks, it reflects a fundamental change in the how and where of the planet's energy balance. This study's quantification, that 0.18 to 0.29 degrees Celsius cubed per decade, gives us a mathematical way to track this breaking of the climate's symmetry. It's a metric for the complexity of the impact, not just the magnitude.
It seems the challenge for the next decade of climate policy isn't just hitting the 1.5 or 2 degree targets, but doing so in a way that addresses this regional drift. If we ignore the asymmetry, we risk a future where half the world thinks we've already failed and the other half thinks nothing is happening. Bridging that cognitive gap requires us to be as honest about the spatial complexity as we are about the global numbers.
And that honesty starts with moving beyond the mean. We have to talk about the divergence as a primary feature of climate change, not a side effect. It's about recognizing that the global in global warming is becoming a collection of increasingly disparate regional crises. If we don't account for that in how we communicate, we're essentially leaving the door open for skepticism to grow in the very places where we need action the most.
The data is clear. The more we emit, the more skewed our world becomes, both physically and perceptually. This research provides a vital roadmap for understanding why the global average might feel like a distant abstraction to many, and why closing that gap is essential for the future of climate mitigation. It's a call for a more nuanced, region-aware approach to both science and policy.
Ultimately, the goal of climate mitigation is to preserve a stable environment for everyone. If our metrics for success don't reflect that regional stability, they aren't telling the whole story. Preventing the climate from tipping into that bimodal distribution isn't just about the temperature. It's about keeping the global community on the same page.
It's about maintaining a shared reality in a world that is physically pulling apart. Understanding warming asymmetry is the first step toward reclaiming that shared narrative and ensuring that our policies are grounded in the actual experiences of people across all 58 of those reference regions. Share this episode with someone who follows climate news to help broaden the conversation beyond just the global average.